Sorry guys, we forgot to hit record. So this isn't too bad then. Okay, so here when that's 0, you can find your horizontal tangents, and when your dx dt is 0, you can find your vertical tangents. Okay. So not too bad. And I always recommend doing like dx dt, finding that, dy dt, finding that, then writing your fraction. Okay? Because you'll want those parts for other things that will happen throughout anyway. Okay? Alright. So now for the second derivative, when you go find the second derivative, you're going to take what you just got for that dy dx, and you're going to derive it. So you're going to do low d high, high d low, all over low low. And then you're going to divide by dx dt. Okay? So this is the part that a lot of students will forget. So really get it engraved. That you're going to do like low d high, high d low, divide by dx dt. And this is the y if you would like to follow along here. Or you can just remember if you just like remembering. Okay? Okay, move on. Let's do an example. So I'm going to find the second derivative as a function of t if I have x equals t minus t squared and y equals t minus t cubed. So the first thing I'm going to go ahead and do is find these individual components, dx dt, dy dt. And then Sarah, what did you get for dx dt? And dy dt? Okay, so, oops, that's a funny screen. So now I can find dy dx is going to be equal to what? Yeah? Good. So we had to get that before I could get to the second derivative. So now we're going to find the second derivative. Can I reduce that? Can I simplify that first off? Alright, so now we're going to go to the second derivative. And we're going to do our low d high, high d low, all over low low, and then add in the extra component part, okay, for parametric. So I'm going to do low d high minus high d low all over low low, and then I still have to divide by dx dt, 1 minus 2t. Now, it just so happened that this is going to be 1 minus 2t cubed. That won't always be the case, okay? Because a lot of times you can simplify your dy dx and different things. So don't just think cubed. Think low d high, high d low, 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 and then divide by dx dt. Okay, now simplify that. Go. And if you want to factor out the 2 in the numerator, go for it, but it doesn't help you, so I don't care. That's all. That's your second derivative. That's all I wanted you to find here was the second derivative. So now that we've all got that, we're going to go to this next problem, which is a little more applicable. Now it says, hey, find the slope and the concavity for that set of parametric equations when t is going to be 2. So to find the slope, I'd have to plug 2 into the first derivative, and to find concavity, I'd have to plug it into the second derivative. Go for it. Again, I always just like to do my dx dt, dy dt first because a lot of times you use those components. It's just good habits. Evaluate that. Let's use 2. So I'll check and see I got a slope of radical 2. If you got that, then keep going. So I like to always factor GCF. So when I get that far, I would always factor the numerator, take out my GCF, and cancel some things. I think that's easier. If you'd like to try to rationalize or whatever, go for it, but I factor my numerator by taking out my GCF. Okay. So in this case, my GCF, I could pull out a 1/2 from both terms. I could pull out a t to the negative 1/2, and I can pull out a t minus 1 to the negative 1/2. So I've gotten rid of this, and then that becomes a 1. See, I got rid of this, and that becomes a 1. here, I can cancel some things. And then I can break that guy down. That would be 3 halves. So that's what I got mine to reduce to. Usually one of the hardest parts when I was simplifying all your algebra in calculating, you don't really have a problem. That's just, I think, the easiest way is to always pull out the GCF. And then you need to evaluate that still. -1, concave, down. Shaped like a frown. Good. So you know that when t is 2, you've got a slope of radical 2 and that it is concave down for this set of parametric equations. Anybody one more time on that? These are so quiet today. It's like 25% of our class. Is that why? No, you guys are the loud ones. Not like you, McKay, you're the loud one. And I'm so tired today, too. Alright, now, a little bit of torture, but a little bit of fun, okay? So, you remember all your formulas for arc length, surface area, all of that for rectangular? Now we're going to go do it with parametric. And then when we get to polar, what are we going to do with it? Polar, okay? So you're going to learn how to do all of these with not only just rectangular form, but with parametric and with polar. But today we're going to do it with parametric. So, let's just first start with arc length. It's not so bad. We're going to take this formula and we're going to manipulate it to see how I could get it into parametric. You don't have to have this process memorized, but it's easy to follow along. Okay? It's just a lot of algebra. Is this familiar? Okay, so all I'm going to do is say the prime is the same as dy dx. Yes? So now that I'm here, what do you think I want to do with my dy and my dx? dy over t over dx dc. Perfect. Alright, so that's your next step. You're going to make it dy dt over dx dc. Okay? So then I'm going to get a common denominator. In order to get a common denominator, I would have to make that dx over dt squared over dx dt squared, right? So then put those together, and in the same process right here, we're going to multiply by dt over dt. Alright, so now I've got those into a common denominator, and I've got that dt dt. Now I want to get rid of the denominator. So if I take this guy, square and square root it, what will that happen? They will cancel, right? So that's what's going to happen here. They cancel. And now you're left with this guy. This dx dt is in terms of t. This dy dt is in terms of t. And then you have dt. There's your equation. Okay? So this is the one you're going to have to remember. And a lot of times, like we said, x is f, y is g, so you can write it like that. Biggest thing to just remember is when you're doing the arc length, you're going to take the derivative of your dx dt, square it, plus, just like before, the derivative of your dy dt, square it. And you still have the radical from a to b. Is that okay? sure we see what it's going to look like. So let's see. In this case, I'm going to have an x, a y, and what else am I going to need? A t. So what t do you think you want to start with? 0, because you're going from 0 to 2 pi. So let's put 0 in. Cosine of 0 would be 1. 1 cubed is 1. Sine of 0, 0 cubed. Where do you want to go next? Go pi over 2? Sure. What happens? They switched. Where do you want to go next? Pi. What do you get here? Negative 1, 0, and then let's go to 3 pi over 2. 0, negative 1, and then back to 2 pi, we are back at where we started, right? And if you want to get more in there, you can. Alright, so let's see. We started, these are our points. Okay, so we started at 1, 0. And then we went to 0, 1. And then we went to negative 1, 0. And then 0, negative 1. And then we're back to where we started. And it's kind of telling you that an asteroid is going to be this shape. And if you want to get more points like pi over 4 and things, you can. That's what it's going to do, okay? It's going to be symmetric. And I need arrows since it's parametric, knowing which direction I'll flow. And then it's just going to keep going over itself infinitely many times. Oh, we're only going from 0 to 2 pi, actually. Okay, so I want to find the length of this asteroid. What can I do, Andrew? Integrate, yes. From where to where? I'm going to bring it up. Where to where? So we're going to be, this is going to be in terms of t's now, right? So you want to go from where? We could go all that way, or what else could we do? We could go 0 to pi, or we could even go 0 to pi over 2 and multiply it by. Alright. I like symmetries. Let's do that. You can pick. I always like to do the most symmetries I can. Radical. Oh man, what do I still need to find? I haven't found yet. The x dt, my dy dt. And I always rewrite it like that when I do my derivatives. So go find those derivatives. Alright, so I find my two derivatives, I put them in and square them with a plus. Yes? Finish this one by hand. And let me tell you what your answer should be. It's 6. Talk within your group, finish it by hand. What do you think you're going to do first? You got to simplify all that inside stuff. It's actually not bad at all. Did you square it? love math. You're all going to say that in just about, I don't know, 30 seconds or so. She was even early. Oh, John, did you say it yet? Come on, John. John loves math. Let's hear it, John. Oh, and I'm ready to sing it. Oh, I love math.
Well, that's what you're supposed to say.
So now that's let's see, that's inside a radical still, right? Did everybody get that far? Am I going too fast? So what's the square root of 9? 3. What's the square root of cosine squared? Oh, and now this is just an easy little use of. Thank you, Sarah.
Excuse me.
So don't forget if you to have it you have to change your bounds.
Whole time.
That's not that much compared to everything. No, I'm just kidding. Every time I think about physics, I cry. So,
Oh.
I'm just kidding. Yeah.
A lot of people don't. Yeah. Yeah. Anybody need more time to get to 6? 2?
Alright.
Can I do that for you?
Just plot everything you know. Everything.
Did you get a formula sheet?
Yes.
Not for the multiple choice.
Yeah.
For the free stuff.
Did you do a calculator on everything?
Not the multiple choice.
Yeah.
Also, it's stupid because I'm like, you can use 10 meters per second squared as acceleration of gravity.
I know.
That is false. You are wrong. No, I
Yeah, you did because
Physics turns around like crazy.
I know.
It's like, come on.
Like on our
You good?
like turning it off.
It's arbitrary. You just have to go through enough digits to where
No, it's not even 6 things. It's like, okay, we got this step, so let's round up. And we got this step, so let's round up. And like, got this step, so let's round up. That's not how rounding works.
Alright.
It's multiple choice. It's not supposed to be crazy hard.
Oh my goodness, I opened a can of worms there.
You did.
I guess. What was I thinking? I thought we were gonna formula sheet. Alright. So, now that we have an arc length, we can revolve it around an axis. Right? Let's say I want to revolve it around the x-axis. So what? I'm creating a surface area, right? Like all of that's just open inside. I can stick my arm through that hole right there. And I'm just looking at that surface area created by the arc length. So if you remember, Formula for surface area, 2 pi r arc length. We had that in rectangular. Same thing here. So we're going to go 2 pi r. The r in this case is which part of the parametric equation? X or y? Y. So whatever y equaled is what you're going to put here in terms of t. So if I took my arc length and revolved it around the y-axis, what is my radius in now? That is an x. X equals whatever in terms of t. So now my radius is going to be x. Is that okay? So it's just remembering those formulas back when we learned them. Now applying them to parametric. Okay. Let's do an example. So we have this parametric equations. X is cosine t, sine, y is sine t plus 1. And we're going from 0 to 2 pi. Find the area of the surface swept out by revolving this circle about the x-axis. So I'm taking something, revolving it around an x-axis. So what am I creating for my radius? It is going to be x or y? Y. So we're going to have 2 pi from where to where? 0 to, oh, it's cut off on yours, 2 pi. Cut off. 2 pi.
Just after that quiz, too.
And what am I going to put for my r? The y, which is what in terms of t?
Yeah.
So that was your y.
I love math.
Yay! Alright, and then we're going to put our arc length. So I need to find what dx dt is going to be, what dy dt is going to be.
Okay, now let's
Now does everyone know why Evan loves math? Not yet? Okay. Almost there.
Let me guess. Say.
So we have negative sine t squared plus cosine t squared dt. And what does all of that radical become? Let's all say it together. I love math. Okay, and so now you can finish that by hand, no problem. And I'll tell you what you should get out. And as soon as you get that, try the last one by yourself. Or with your group or whatever, but. of those if you haven't. Okay. How does a mathematician induce good behavior in her children? If I told you n times, I told you n plus 1 times.
Can you explain one to me?
What?
Can you explain that one to me?
Because it's like if I, because if I told you 1 time, I told you 100 times. You know how they always say that? Okay, so this is like, you know, in sequences and series, like you have n and then n plus 1. If I told you n times, I told you n plus 1 times. Don't. I didn't know how to picture my kids. Okay, anyway.
Summation of 1 over n times.